Hello dear students, how are you all? I'm Meenal Murhekar, welcomes you all in the online tutorial. So, how are you all? Have you utilized your vacations nicely? Yes. So, now we are going to start with the next part of your science textbook, that is from the chemistry portion. We are going to start chapter number 3, that is metals and non-metals. So, according to the CBSE, some portion of from this chapter is reduced by them. So, we are going to study the remaining part from this chapter, and that portion that is reduced is some metallurgical processes, means the extraction and the corrosion and its prevention. This part is reduced. So means in this portion they have eliminated all the occurrence of metal, extraction of metal, then enrichments of ores, extracting metals low in the activity series, extracting metals in the middle of the activity series, then extracting metal towards the top of the activity series, refining of metals, corrosion and its prevention of corrosion. This all portion is reduced by them. So in this chapter now we are going to learn only about the physical properties of metals and non-metals, and about the chemical properties of metals and non-metals, and the bonds and the adherence or the groups formed by the elements. So this is what we are going to learn in this chapter. Okay, so first we are going to start with metals. So we are going to see the physical properties of metals first. So first we'll discuss about some physical appearance, that the properties which we can see through the appearance, that we are going to discuss first. The first property of metal is luster. So metals have shiny surface, example gold, silver, etc. So gold, silver, these are the metals which have luster on their surfaces, right? Means shiny surfaces they have. So they have luster on the surface. Second point is hardness. So metals are generally hard. Yes, we know this thing that metals are generally hard. We have seen the almirah. Almirah is made up of iron. Table is made up of iron. Chair. These all things are made up of iron. So these are what? Iron, copper. Our utensils are made up of copper. These are what? These are hard. So metals are generally hard. Except few metals are not hard, and these metals are sodium, potassium and lithium. So these three are the metals which are not hard. They are as much soft as they can be cutted by the knife. These elements are very soft and can be easily cutted by knife. Now the third point about their physical property is state. So in which state they occur? Metals occur in a solid state. Yes, we have seen these states, that is solid, liquid and gases. So metals exist in solid state except mercury. Why? Because mercury is liquid in state. You have seen mercury in thermometers, right? So mercury is a metal, and it is the only metal which exists in a liquid form. Now see fourth point. Fourth point is malleability. Malleability means what? Metals can easily beaten into thin sheets. Means metals have the property that if they are beaten, they can be converted into thin sheets. So this property is known as what? Malleability. And yes, metals do show the this property, that is malleability. You have seen gold and silver ornaments. So you have seen that in thin sheets or in thin wires, um, these metals are converted, and our ornaments are made in this way. So metals can easily beaten into thin sheets. Like gold and silver are the most malleable metals. These are the most malleable metals. You have also seen copper and aluminium wires. Yes, copper and aluminium wires are used in our electric connections. Yes, so these are because of these malleability only, these metals are getting converted into these forms. Next property is ductility. Ductility is what? Metals can be drawn into thin wires. Yes, metals can be drawn into thin wires. Earlier we have seen, right now we have seen. So metals can be drawn into thin wires, and examples of that are copper and aluminium. Next property is conductor of heat and electricity. So here we are going to discuss about the conduction of electricity, whether the metals are good conductors of electricity or not. So here we have seen that metals are the good conductors of heat and electricity, except see, silver, copper are the best conductors of electricity. Means silver and coppers are the best conductors of electricity. That's why our wires, the electric wires are made up of copper only. Okay. Now density. What is the density of solid? Generally metals have high density and high melting point. These have high density and high melting point too. Means if you want to melt any metal, then you have to give much amount of heat as compared to that of liquid and as compared to that of the gas. So generally metals have high density and high melting point. Exception are still there, and the exceptions are sodium, potassium and lithium. Why? Because they have low melting point and low boiling point too. The density of sodium, potassium and lithium is very less. That's why they have low melting and boiling point. Next property is sonorous. Sonorous means which makes sound while beating. So metals are sonorous. When metals strike to hard surfaces, they produces sound. Example, bell. Yes, bell is made up of metal, and when we strike that with a hard substance, it makes sound. So this is known as sonorous property, and yes, metals do exist this property. Next part is oxides. Okay, oxides. Now here we are going to talk about the oxides too. So oxides of metals are basic in nature. Metallic oxides are basic in nature. Whatever oxides means what? The combination of metal with oxygen. So when these metal combine with oxygen, it forms a basic oxide. Means the nature of that oxide will be basic. Okay. So this is what we have discussed about the physical properties of metal. So in this same manner, we are going to discuss the physical properties of non-metals. Okay. So see, physical properties of non-metals. First is luster. Okay. First is luster. Now start comparing with this physical properties of metals and non-metals. Luster. Non-metals do not have shiny surfaces. Non-metals do not have shiny surfaces except iodine. Iodine has a shiny surface. It is the only non-metal, iodine is the only non-metal which have a shiny surface. Okay, next point is hardness. Hardness. So non-metals are generally soft. All we have seen in the case of metals, that all metals are hard, while non-metals are generally soft, except diamond. Diamond is the non-metal which is hard. Okay. Do you know diamond is made up of what? Diamond is made up of carbon, and carbon is a non-metal. So it is only non-metal which is hard. Okay. Third is state. We have seen that metals exist in solid state, but here non-metals exist in solid and gaseous state. Okay, all the non-metals exist in solid and gaseous state except bromine. Bromine is the only non-metal which exists in liquid state. Now the next point is malleability. We have seen that all metals are malleable in nature, while non-metals are non-malleable. Ductility. Non-metals are non-ductiles. Means this non-metals cannot be easily converted into thin sheet, nor they are converted into thin wires. Okay. Conductors of heat and electricity. We have seen that metals are good conductors of electricity, but here we are going to see that non-metals are poor conductor of heat and electricity, except graphite. Again, graphite is a form of carbon, and this is the non-metal. Means graphite is a non-metal, or you may say carbon is a non-metal which is a good conductor of heat and electricity too. Okay. Now the next point is density. When we talk about the density of the non-metals, generally non-metals have low density and low melting points. We have seen that metals have high density and means they are solid in state, that's why the density is high, and they have high melting point too. But here non-metals have the low density and low melting point. Next is sonorous. Non-metals are not sonorous, means they cannot create a sound, they cannot produce a sound while they are beaten with anything. Okay, when non-metals strike to a hard surface, they don't produce any sound. Next is oxides. Non-metallic oxides are acidic in nature. We have seen that metals produces basic oxide while they react with oxygen. But here, when non-metals react with oxygen, they form acidic oxides. Okay, so this is the comparison of physical properties of metals and non-metals. Now we are going to see about the chemical properties of metals. So in chemical properties, we are going to see the reactions of metals and non-metals with water, air, acids and bases. Okay, so first here we are going to start with reactions of metal with air. Okay, first we will cover all the reactions of metal, and then we are going to cover the reactions with non-metals. So see, reactions of metal with air. Metal combined with oxygen to form metal oxide. Metal combines with oxygen to form metal oxide. Okay, so here we are talking about oxygen, and we know that oxygen we obtain from air only, that's why we have written oxygen here. So metal when reacts with oxygen, it forms metal oxide. Okay, so just see the example. C 2Cu plus O2 gives 2CuO. Means here when copper is reacting with oxygen, it forms copper oxide. When aluminium reacts with oxygen, it forms aluminium oxide. 4Al plus 3O2 gives 2Al2O3. Okay, now different metals show different reactivities towards oxygen. We in general we have seen that any metal when reacts with oxygen, it forms metal oxide, but different metals show different reactivities towards oxygen. So here see, sodium and potassium Na and K react so vigorously that they catch fire if kept in open place, so that they are kept immersed in kerosene oil. Means here we want to convey that sodium and potassium react so vigorously. Means sodium and potassium in presence of air, they react so vigorously with the air that if they are kept open, if they are not covered, then they easily catch fire. That's why the sodium and potassium are kept immersed in kerosene oil. So in kerosene oil, in the closed vessel of kerosene oil, air will not reach there, and that's why they are kept immersed in that, so that they cannot catch fire. Okay, now surface of magnesium, aluminium, zinc, lead are covered with a thin layer of oxide which prevents them from further oxidation. Now here we can see that surfaces of magnesium, aluminium, zinc and lead, these metals form a thin layer of oxide around them, so that they cannot they so that they can be prevented from further oxidation. Okay, means you have seen aluminium forms a greenish layer, or silver forms a greenish layer, that is oxide layer, and aluminium too forms an oxide layer around it. So this oxide layer is there to prevent these metals from further oxidation. Okay, now Fe does not burn on heating, but iron filings burns vigorously. Means in presence of air, Fe does not burn. Iron does not burn in the presence of air, but the iron filings burns vigorously. Cu does not burn, but the coated with black copper oxide. Cu does not burn, but coated with black copper oxide. copper does not get burned, but it is coated with black copper oxide. Okay, next is Au and Ag. Silver, gold and silver does not react with oxygen. Yes, we know this thing that gold and silver does not react with air. That's why we used to wear the ornaments made up of gold and silver. So they does not get oxidized, or they does not form any layer. But still, sometimes silver get oxidized. It reacts with the atmospheric oxygen and form a blackish layer over the surface, but gold does not completely react with oxygen. Now the next point is amphoteric oxides. What are amphoteric oxides? See, metal oxides which react with both acids as well as bases to produce salt and water are called amphoteric oxides. See, metal oxides which react with both acids and base as well as bases to produce salt and water are called amphoteric oxide. This reaction we have seen in neutralization reactions too. Yes, when metals and non-metals reacts with when acids and base both reacts with each other, they form salt and water. Yes, so in the same manner here, when metal oxide reacts with both acids and bases, they produce salt and water, and that's why these metals are known as what? Amphoteric. Amphoteric. Why amphoteric? Because these types of metals react with both acids and bases. So see here, Al2O3. Al2O3, Al2O3 is a metal oxide, and this metal oxide when reacts with HCl, that is an acid, it forms a salt, that is AlCl3, and H2O is released. See here. Yes. Now, see, when this same oxide react with base, Al2O3 when reacts with the base, that is 2NaOH, it forms a salt, that is 2NaAlO2. Okay, 2NaAlO2 plus H2O, water is released. So, in both the cases, what is happening? Salt is formed and water is released. That's why these metal oxides are known as amphoteric oxides. Okay. Now, see chemical properties of metals. In this, the second reaction is in the chemical properties of metal. Second reaction is reactions of metal with water. Till now, we have seen the reaction of metals with air. Now, we are going to see the reaction of metals with water. So, when metal reacts with water, it forms metal oxide or hydroxide plus hydrogen is released. Okay, and when this metal oxide reacts further with water, it forms metal hydroxide. Okay, so here we have written metal oxide and hydroxide too. So we have to we will think that which metal will form oxide and which metal will form hydroxide. So it depends on the basis of the reactivity of metal. So highly reactive metal will form hydroxide directly. Highly reactive metal when reacts with water, they will directly form a hydroxide of that metal, while the least reactive metal will form a metal oxide. Okay. Example, when sodium reacts with water, it forms NaOH and H2 gas is released. Now here NaOH is what? NaOH is a hydroxide. What we call NaOH? NaOH is sodium hydroxide. Okay, we does not call this as a oxide, sodium oxide, and here OH is there, that means hydroxide is formed. So sodium hydroxide is formed. As we know that sodium is a more reactive metal, that's why it directly formed hydroxide. See next example, calcium when reacts with water, it forms calcium hydroxide, 2CaOH whole twice plus H2 plus H2. Calcium when reacts with water, it also forms calcium hydroxide and water is released. Now in the next example, when iron reacts with water, it forms iron oxide plus hydrogen gas is released. 3Fe plus 4H2O. When reacts with each other, it forms iron oxide. Fe3O4 plus hydrogen gas is released here. Yes, here hydrogen is released and oxide is formed here. As iron is less reactive as compared to calcium and sodium, that's why it has formed oxide first. And when these oxide react with further, it will react with water, then it will definitely form hydroxide. Okay, iron hydroxide will be formed. Now, the reactivity of metals with water is different with different forms of water. Means forms of water means vapor form, cold water, hot water, steam water. So with these forms of water, different metal react differently. So let's see. Sodium, potassium and calcium reacts with cold water. When sodium, potassium and calcium only reacts with water when the water is in cold form, when the water is cold. Aluminium, iron and zinc react with steam. Aluminium, iron and zinc only react with water when it is steaming, when it is vaporizing. Okay, when steams are coming out of water, at that time only aluminium, iron and zinc will react. Magnesium react with hot water. To hot water, magnesium will react. Calcium and magnesium float on the water surfaces as bubbles of hydrogen stick to their surface. What happens in the reaction of calcium and magnesium? Calcium and magnesium will float on the surface of the water, while the bubbles of hydrogen, when the hydrogen is released, so when anything is released, bubbles of the air will form. So we have seen that in some reactions CO2 is released, so popped sound is there. Yes, it is evolved, and when we used to check it, so a pop sound is there. So in such a manner here, hydrogen is getting sticked to the surface. The bubbles of hydrogen are getting stick to the surface of the vessel, while calcium and magnesium are floating on the surface of water. Next is gold and silver. Gold, silver, copper and lead does not react with water. So these are the exceptions of these reactions, that gold, silver, copper and lead does not react with water. Okay, so in this part what we have learned, that when metals react with water, it forms oxide or hydroxide, plus they they release hydrogen gas. The more reactive metal will form hydroxide directly, and the less reactive metal will first form an oxide, and with further reaction of that oxide with water, it will form hydroxide. Okay, now the third reaction is reaction of metals with acid. It is the third property, reactions of metals with acid. Now here, when metal reacts with dilute acid, it forms salt and hydrogen. Here we are using a term dilute acid. Why dilute acid? Because we cannot we cannot perform any chemical reactions with the concentrated acid, because we know these things. We know the fact that concentrated acid are highly dangerous and they can harm us too. So that's why all the reactions which are performed here, these are done with dilute acids only. So metal, when reacts with dilute acid, it forms salt plus hydrogen. While reacting metals with concentrated acid, exothermic reaction will occur. If any metal reacts with a concentrated acid, then exothermic reaction will happen and a huge amount of heat will be liberated. That's why we does not perform any of the activity with concentrated acid. Now see the example of this. When iron reacts with HCl, it forms FeCl2. FeCl2 is what? FeCl2 is a salt here and H2 is released. Another example, when aluminium 2Al reacts with HCl, dilute hydrochloric acid, it forms 2AlCl3 plus 3H2 is released. Okay, so here when metal reacts with dilute acid, it forms salt and hydrogen. Next property is reaction of metal with the solution of other metal salt. Means here we are going to learn a metal is reacting with the salt of another metal. Okay, so reaction of metal with the solution of other metal salt. So here when metal A plus the salt or salt solution of metal B reacts with each other, they will form salt solution of A and metal B will be separated out. So here we are seeing that a displacement of metal is taking place. A displacement reaction is taking place. Here what is happening? We are reacting metal A. One metal when we are reacting with the solution, salt solution of another metal. So metal A is displacing metal B from the salt solution and it is taking place in the salt solution, means metal A is forming a salt solution while metal B is separated out from the salt solution. So here see, metal A will displace metal B and form its salt solution. So here you can see the example Fe plus CuSO4 when iron reacts with a copper sulfate. Copper sulfate is a salt solution of copper metal. Copper here it is a metal and metal solution, salt solution of metal B, that is copper sulfate. So when iron reacts with copper sulfate, it displaces. Here see Cu is displacing Fe. Here this Cu is displacing Fe. Here FeSO4 is formed, right? FeSO4. FeSO4 is formed and this Cu is separated out from the salt solution. So in this way a displacement of metal is taking place in this reaction. So when metal A reacts with the salt solution of any other metal, a salt solution of metal A will form and metal B will be separated out. So in this way the reaction of any metal with the another salt solution of any other metal will take place. Now, here we are going to learn about the reactivity series. In this all reactions we have we have talked about the reactivity of the metal, which metal is reactive and which metal is least reactive, which is more reactive. So it depends on the basis of this reactivity series. On the basis of reactivity series we can decide that which metal is more reactive and which is least reactive. Okay, so here a list of metal is given. See, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver and gold. So in this way, in the decreasing order, a reactivity series is given. It is a list of metal arranged in decreasing order of reactivity. Okay, so the element which is written on the top of the list, it is more reactive, while the metal which is written in the end of the list, it is a least reactive metal. So here we can see in the most reactive metals, sodium, potassium, calcium, magnesium, aluminium. These are what? These are most reactive metals, while silver, gold, mercury, these are what? These are the least reactive metals. Okay. So on the basis of this reactivity series, we can decide whether the metal is reactive, more reactive or least reactive. Okay. So now see, fifth property is reactions of metals with non-metals. As we have seen the reactions of acids with base, in the same manner we are going to see the reactions of metals with non-metals. So in the reaction of metals with non-metals, few points are there which we have to discuss first, and after that we are going to see the reaction. So first point is reactivity of element is the tendency to attain a completely filled valence shell. Yes, we know this thing that elements react with each other, or element forms molecules to stabilize themselves or to attain the complete filled valence shell. Yes, we know that valence shell is the outermost shell, and to satisfy, to attain the completely filled shell, uh, to fill or to attain the completely stabilized valency, these elements react with each other to form molecules, or they combine with each other. So reactivity of element is the tendency to attain a completely filled valence shell. Why they react with each other? To fill their valence shell. So how they stabilize themselves, or how they attain the completely filled valence shell? So metal lose electron from their valence shell to form cation. Cation means what? Positive charge. Okay, so metal lose electron from their valence shell, from their outermost shell, to form a cation, means a positive charge they will attain. When they lose electrons to get stabilized, they will gain a positive charge on them, while non-metals gain electron in their valence shell to form anions. While non-metals gain the electrons from the metals, and they will gain a negative charge on them, and that's why they are known as anions. Okay, means no, metals will always form cations, while non-metals will form anions. Okay, so the compound formed by the transfer of electrons from metals to non-metals are called ionic compounds. Okay, the compounds formed by the transfer of electrons, means metals have the tendency to lose the electrons, while non-metals have the tendency to gain the electrons. So the compounds formed by the transfer of electrons from metals to non-metals are called ionic compounds or electrovalent compound. The compounds which are formed by the transfer of electrons from metal to the non-metals, means when metal loses electron and non-metals gains the electron and form a compound. That compound is known as what? Ionic compound or electrovalent compound. Okay, is it clear? So on the basis of these losing and gaining of electrons, metals and non-metals reacts with each other and form a compound known as ionic compounds or electrovalent compound. Now further we are going to see the reaction of metal with non-metals. So with the example of formation of NaCl, sodium chloride, here sodium is a metal while chloride is a non-metal, we are going to see the reaction of metal with non-metal. So here let's just see. Sodium is a metal. Here we have written the element, that is sodium and chloride. So electronic configuration of sodium is, the electronic configuration of sodium is 281. Okay, while the electronic configuration of chlorine is 287. In the valence electron, sodium has 1 electron while chlorine has 7 electrons. Okay, see here we have denoted only the valence electron. Sodium has 1 electron in the outermost shell while chlorine has 7 electron in the outermost shell. Now here sodium has 1 extra electron in its outermost shell, means if it loses its 1 electron from the outermost shell, it will attain the stable electronic configuration, means 28. What is the stable electronic configuration of the third orbit? 288. 8 electrons must be there in the third orbit too to fulfill the 18. 18 electrons or 8 electrons must be there to attain the stable electronic configuration. Yes, means almost 8 electrons are required by the sodium atom to gain the stable electronic configuration of the third orbit. But here it has another option, alternative it has, that it can lose one electron and it will attain the stable electronic configuration of the second orbit. Yes, it is the most simplest way to obtain the stable electronic configuration of the second orbit. 2 8 means total of 10 electrons, so it is the stable electronic configuration. So here what sodium will do, it will just lose its one electron, and here chlorine has 7 electrons in the outermost shell, in the valence shell, and it requires only one electron to stabilize itself. So what chlorine will do, sodium will lose its one electron and chlorine will gain that electron, chlorine will gain that one electron. So when sodium will lose its electron, one electron, it will gain one positive charge. Why one positive charge? Because only one electron is reduced, one electron is lost. So that's why only one positive charge will be there. Okay. One positive charge will be there and chlorine will gain that one electron and it will gain one negative charge. Means here sodium will get converted into sodium cation and chlorine will get converted into chlorine anion. Okay, so the charge depends on losing and gaining of electrons. When an element loses electron, it will gain positive charge, while when an element gains electron, it will gain a negative charge. Or you may say a metal always loses its electron and it will gain a positive charge, while a non-metal will always gain the electrons. It will borrow the electrons from the metal, so it will always gain a negative charge on them. So here after gaining and losing of electrons, the electronic configuration will be in this manner. When sodium loses its electron, see sodium, when sodium loses its electron, it will, here what is formed, sodium Na plus and electron. Okay, so the electronic configuration will be here. The electronic configuration, if we talk about the electronic configuration of sodium, we know that the electronic configuration of sodium is 281. But after losing of one electron, what is happened here? The electronic configuration of sodium plus will be 28 and one electron is lost here. So the electronic configuration here, sodium has attained the stable electronic configuration, that is 28, and one electron is released, one electron is lost. Now in case of chlorine, if we talk about the chlorine, chlorine has the electronic configuration of 287. Here we have seen that the chlorine has 287 electronic configuration, but when it gains the electron from sodium, here when it gains one electron from sodium, it will form a chlorine anion is formed and the electronic configuration is 288. Now it will attain the 288 electronic configuration. 288 is the stable electronic configuration for chlorine. In the third orbit 8 electrons are there, so 288 means 18 electrons are there in the third orbit. So chlorine has also attained a stable electronic configuration, means the valence shell of both the elements have stabilized themselves. So in this way, through the losing and gaining of electrons from metals to non-metals, a new compound is formed, and that compound is known as what? Sodium chloride. Yes, sodium chloride is formed by the ionic transfer, or it is electronic transfer. That's why electronic transfer or mutual sharing of both the electrons, that's why these compounds are known as what? ionic compounds or electrovalent compounds. Okay, so here sodium chloride is formed. Is it clear to all of you? Yes, now we are going to see the another example, that is aluminium chloride, AlCl3. See, here we have a written element, that is aluminium and chloride. The electronic configuration of aluminium has the electronic configuration of 2, 8 and 3. Yes, 2 in the first orbit, in second orbit it has 8 electrons, while in the outermost valence shell it has 3 electrons. In the same way, we have written the electronic configuration of chlorine, that is 287. Yes, in the previous example we have seen this. So now aluminium has 3 electrons in its valence shell, means it has two options. It can lose 3 electrons or it can gain 5 electrons. But to gain 5 electrons, more energy will be required. Yes, more energy will be required, and to lose 3 electrons, a small amount of energy is required. So what it will do, it will do with its conveniency. So the losing of 3 electron is more easier than gaining 5 electrons, right? So here aluminium will do what? It will lose its 3 outermost electrons. Okay, and chlorine, here 3 chlorines are there, AlCl3. 3 chlorines are adhered with the aluminium. So three chlorines require 3 electrons. So these 3 electrons, chlorine will acquire these 3 electrons from the aluminium. So let's just see here. We have denoted all the 3 outermost electrons of aluminium here, and we have written a positive 3 charge on the aluminium. Why we have denoted with the 3 plus? Because all the 3 electrons are loosened by aluminium. Okay, now here we have clearly denoted the 7 electrons of the outermost shell from the chlorine, and each chlorine has a negative charge on them, because 1 electron, each chlorine is gaining 1 electron from aluminium. So here you can see this electron is given, this electron is given to this chlorine, this electron is given to this chlorine, and this is to this chlorine. So in this way, all the 3 outermost electrons from the aluminium valence shell are loosened by aluminium and gained by these 3 chlorines. Now we'll see the electronic configuration of aluminium here. So before losing electrons, aluminium has 283 electronic configuration, while after losing, the electronic configuration of aluminium will be 3 electrons are loosened. So here aluminium will have a positive charge here. I have not written a positive charge here, but a positive charge will be there. Here you have to mention 3 plus charge. Okay, 3 plus charge. Aluminium has 3 plus charge, means it has loosened 3 electrons. So the electronic configuration will be 2, 8 plus 3 electrons are loosened, that's why 3 electrons. And here in case of chlorine, you can also write in this way here, the electronic configuration 3Cl when 3Cl when gains the electron, these 3 electrons, you can directly write here 3 negative charge. 3Cl has 3 negative charge. Okay, so the electronic configuration will be 287 plus 1, 288, 287 plus 1, 288, 287 plus 1, 288. So in this way, the electronic configuration of chlorine will be satisfied. So in this way, both the outermost valence electrons of aluminium and chloride will attain the stable electronic configuration, and they will form a compound known as aluminium chloride, and the formula of that will be AlCl3. Okay, So in both the cases, these opposite charges attract each other and are held by strong electrostatic forces to exist as sodium chloride and aluminum chloride. Yes, here you can say that these ionic compounds are formed on the basis of what? On the basis of attraction of positive and negative charges only. Yes, so in both the cases, these opposite charges attract each other and are held by strong electrostatic forces to exist as sodium chloride and aluminum chloride. It should be noted that sodium chloride does not exist as a molecule, or aluminum chloride does not exist as a molecule, but aggregates as a oppositely charged ion. Both these elements, sodium and chloride and aluminum and chloride, both these elements are getting aggregated with each other. Yes, these are not forming a molecule. Molecule are formed by whom? These are forming a compound. These are aggregating themselves with each other, and molecules are what? O2, H2, N2. These are what? These are molecules. And here they have formed a compound by aggregation. So it should be noted that sodium chloride does not exist as a molecule but aggregates as a oppositely charged ion. Okay. So this is about, this is in this way a ionic compound is formed. Okay. Now see, the compounds formed in this manner by the transfer of electron from a metal to a non-metal are known as ionic compounds or electrovalent compounds. Okay. Now we'll discuss further few properties of ionic compounds. Okay, so first see the properties of ionic compound. First is physical nature. So they are, ionic compounds are, you can just open page number 49 from your textbook. I'm reading that from there only. Ionic compounds are solids and are somewhat hard because of the strong force of attraction between the positive and the negative ions. These compounds are generally brittle and break into pieces when pressure is applied. Means they are solid and hard. Ionic bonds formed between metals and non-metals are hard. Ionic compounds are solid and are somewhat hard because of the strong forces of attraction. Here the attraction of positive and negative charges is taking place. That's why they are forming a hard bond. Okay, so these compounds are generally brittle and break into pieces. अगर हम if we apply more forces, then they will broke up into pieces if more external pressure is applied on them. Next is melting and boiling point. Okay, so ionic compounds have high melting and boiling point. This is because a considerable amount of energy is required to break the strong interionic attraction. So they have high melting and boiling point. Why? Because the attraction between these elements is strong. A stronger interionic attraction is there. So because of that forces only, it's means high amount of heat is required to melt them. Okay, and boil them. Okay, so these ionic compounds have high melting and boiling points. Third point is about solubility. Electrovalent compounds are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. These are soluble in water but not in kerosene, petrol, etc. Okay. Fourth point is conduction of electricity. The conduction of electricity through a solution involves the movement of charged particles. Yes, for the conduction of electricity from this ionic compound, movement of charges will take place. Charged particle will take place. A solution of an ionic compound in water contains ion. It will be diffused in form of ions, which move to the opposite electrode when electricity is passed through the solution. Means when we pass the electricity from this solution, what will happen? The ionic compound will diffuse in the form of ions, positive and negative charge. And when we pass electricity from any solution, so what we used to do, we use electrodes in a beaker. Yes, one positive electrode is there and another one is negative electrode. So here what will happen, the positive charge will attract the negative electrode, while the negative charge will attract the positive electrode. So in this way the ions will accumulate, the oppositely charged ions will accumulate on the electrodes. So ionic compounds in the solid state do not conduct electricity. uh, just see, a solution of an ionic compound in water contains ion which move to the opposite electrodes when electricity is passed to the solution. Ionic compounds in the solid state do not conduct electricity because the movements of ions in the solid is not possible due to their rigid structure. But ionic compounds conduct electricity in the molten state. So this is possible in the molten state since the electrostatic forces of attraction between the oppositely charged ions are overcome due to the heat. Thus, ions move freely and conduct electricity. So from here we can conclude that in a molten state, ionic compounds can conduct electricity. Okay, so in this way we have gone through the chapter. In this chapter we have learned about the physical comparison between metals and non-metals, and we have gone through the chemical properties of metals, while we have seen the reactivity of metal with non-metals too. And we have seen the formation of ionic compound because when metal reacts with non-metal they form ionic compounds. So in this chapter we will learn till here only, because the second part of the chapter is occurrence of metal, that is extraction of metal, enrichment of ores, and extracting metal from the activity series, and refining metals, corrosion and its prevention. So for this year only we are going to learn till here only. So in this way we have completed our chapter. Okay, so if you have any doubts you just can go through your NCRTs, your textbooks, and through these notes too. And these notes will be provided to you in a PDF form, so no need to worry about this. So just go through this chapter, and if you have any doubts just you can ask me anytime. Okay, so all of you just take care and keep learning.